Hi, my name is Rose Waugh and I'm a final year PhD student at the University of St Andrews in Scotland, where I work with Moira Jardin. Magnetic confinement of material can take many forms, and one example is slingshot prominences, where cool condensations of coronal plasma get trapped by large closed field lines. They can be ejected from the star and contribute to the spin down of young stars, and they can collide with orbiting exoplanets. What I've done is model the shapes of field lines that could support these slingshot prominences through force balance, balancing the magnetic, gravitational, and centrifugal forces. And we find that there are two types of loop: the solar-like ones close to the surface with empty summits and dense foot points, and the tall slingshot loops with very dense summits. And these form above the co-rotation radius, where the centrifugal and gravitational forces balance out. The H-alpha dynamic spectra can be plotted for a set of these solutions, and I've shown them in figures 4 to 7 for different background fields. And the blue field lines here are the shapes of the cooled field lines, so the solutions that have adjusted from the background field due to the extra prominence mass that they're having to support. And the purple parts of the field lines show the sections that would transit the disk and therefore be present in the H-alpha trails as absorption features. The H-alpha trails look similar to the observed trails for stars like AB Dor or Speedy Mick, but ultimately they look quite similar between the different background fields that have been used here. And the only one that has particularly distinct features is the equatorial dipole. And this suggests that many different field structures could support prominences, and that therefore these slingshot prominences should be very common amongst young and low mass stars. Thank you for coming to my poster, and feel free to reach out by email, which is at the top of my poster, or by any other method.